All right, today we're going to focus on muscles and try and relate back to bones, because kind of remember that one of the functions of a bone was support for connective tissue. So the bones are going to support the connective tissue, and the connective tissue is going to be the muscle. And so, just for an example here, what I'm really looking at would be the posterior view here, and I'm looking at the posterior view of the leg. So if you kind of position yourself here and think where my pen is, that's where the femur would be up here. So where my pen is really located, that would be your femoral condyles. And then I've got a muscle, as you notice, that's coming down here. And then it looks to me like I got this really, really, really thick tendon that's ending up down here. So kind of think, if you just try and picture this, that down here is this tendon. So there's be your Achilles tendon. This would be this extension of the Achilles tendon going to this muscle called the gastrocnemius. And then up here, that's where the top of the muscle is going to be the femur. So the femur is coming down. So this muscle that we call the gastroc or gastrocnemius has what's called a fixed end. And the fixed end is always called the origin of the muscle. So every muscle we look at, and I'll kind of just show you in a minute in the book about how these muscles are and how many there are. You realize there's 657 skeletal muscles, and I don't expect anyone would be able to know all the origins, insertions, actions, innervations, synergists, antagonists of each muscle. We want to look at specific muscles. We want to know position of certain muscles, function of certain muscles. So, if again, as I'm looking at this muscle, kind of think that if this muscle is called the gastrocnemius, this origin would be up here, so the origin would be the femur or the femoral condyles. This is called the body of the muscle that I'm kind of running down. This would be the Achilles tendon, and this down here would attach to, that would be the insertion. And so this muscle itself really inserts on the calcaneus. Remember, the calcaneus is going to be a tarsal bone, is going to be a heel bone, is going to be an ankle bone. And that's what's really significant to start talking about muscles, thinking where things are. So many students take an anatomy class and memorize a bunch of origin, insertions, actions, but then they say, well, where is the muscle? Answer is, I really have no idea. So that's the first thing, how I want to picture things. So let me move this gentleman aside just for a second. And we're going to just take a look at where we kind of started out. So just kind of think that if this was our femur, so therefore these are our femoral condyles. So that is actually where the femur is, that muscle is attaching to, okay? So if you kind of look up here, this is where think of this as being the anterior surface, but remember that's a posterior muscle. So this is where the patella would be sitting. So when I was looking at that muscle man, I'm looking how he's attaching to these what are called the condyles or epicondyles of the femur. And that's why this muscle is very, very strong, and it's got a lot of strength because it's attached to the longest, strongest bone, which is the femur. So now if we put that aside and kind of think of representational anatomy and get some definitions down as to things, we can start out and just say, well, the first thing we need to know about a muscle is its O, and the O equals the origin. And the origin, just like I showed you, is going to be the fixed end of a muscle. And therefore, you also want to think, what might the origin be? And therefore, the origin could be, an example could be a bone, but it also could be a muscle. So it doesn't always have to be a bone. Like when I start talking about my face, my muscles of facial expression actually are, many of them are just going to be inserted onto another muscle or have an origin on another muscle. The other thing, of course, is the eye. So when I showed you that muscle and I said it inserted on the calcaneus, the I stands for the insertion. And the insertion we're going to think of as the movable end. And again, we're going to think that the movable end could be insert on a bone or could insert on a muscle. So again, when I think of the good example of that, if I was talking about the gastrocnemius, it's very easy to think how that's a bone. But just think of how I talk about my face, it's going to be inserting on muscles. So that's why you always think of facial injuries or facial reconstruction, is that you don't have those hard surfaces of a bone that you have to work with. Then remember, a muscle has to do something. So there's something called the A, and A is going to stand for the action. Basically, the action is what the muscle does. And then we've got to have an N. And an N is going to stand for the nerve supply. And sometimes people call the nerve supply the innervation. Well, remember, whenever we do something, we've got to have very fluid movement. So when I'm walking or when I'm moving my arm, so as I'm sitting here moving my arm right now, you notice I'm extending my arm and I'm flexing my arm. But those muscles are working together, even though those muscles are antagonistic to one another. They're helping me have this very fluid movement. Okay, so when I think these muscles here, right here, so this would be like my biceps, my brachialis, my brachioradialis, those muscles are actually flexing my forearm. They're flexing. But at the same time, on the back of my arm are going to be muscles. The muscle is going to extend my arm. So as I extend my arm, I'm going to use the triceps brachii. But when this muscle's working to flex, this muscle in the back is not sleeping. It's working in combination with it, so I don't have a jittery movement, so it's very fluid. So that's why it's so important, when you have an injury, that the person allows for that, ability to move and have that nice fluid movement so it isn't very tight, and that's why you end up having a lot of physical therapy after an injury or muscle repair. Well, then, of course, there's the muscles called the syn, S-Y-N, which stands for synergist. And the synergist is going to assist. And we're going to learn about a muscle that is the main muscle for a given action. And so, for example, it's going to assist the agonist. And the agonist is called the prime mover. And I'll give you an example of that in a second, once I move on a little bit here. But I just want you to get these words down, because once you start knowing these words, trying to get this to kind of get in the screen, okay? Then I've got an A&T-A, and A&T-A is going to be antagonist. And the antagonist is going to work against. And it's going to work against the prime mover or the agonist. Okay? So just like a minute ago I showed you how when I was moving my arm, when I flexed my arm, I was using my biceps, my brachialis, my brachioradialis. When I extended my arm, I was using my triceps on the posterior surface. But again, just remember, while one muscle is flexing, that doesn't mean the other muscle is just sleeping. It's actually keeping a certain amount of tension on the muscle, so I have that nice fluid movement. So now we looked at that, what I call the muscle man, and I'm not going to pull him up again for you, but I'm going to kind of draw out how I would look at it in really representational anatomy. And so I'm going to look at what I would call really the posterior surface of your femur here. And so therefore this is my femur. Remember, the femur is going to be the longest, strongest bone. These are going to be attachment points. So right around here I could put some attachment points. And I would say we could call this a condyle. And this could be called a epicondyle. Because remember, a muscle's got attached to something, and it's got, in this example, it's got attached to a pretty strong bone. And the muscle we're really going to take a look at right now is the muscle that I just showed you, called the gastrocnemius. And the gastrocnemius is often going to be called the gastroc. It's also going to be called the calf muscle. And oftentimes people say it's called the ballerina muscle. And it got its name as the ballerina muscle because this muscle is really responsible for standing on your toes. Standing on your toes, you may recall, is called plantar flexion. So therefore, a ballerina plantar flexes or stands on her toes, and this is the muscle responsible for standing on your toes, or plantar flexion, again called the gastrocnemius. So I'm going to take this muscle and I'm going to just kind of start up over down here, kind of bring it down, and just kind of representationally show you what I really did on that, what I call the muscle man. And I'm going to say that going up here, let me just zoom this out a little bit. So this again is going to be the condyle and the epicondyle. So both of these are going to be what are called the origins. So the O, or the origins of the gastrocnemius, is going to be the femur. Specifically, it's going to be what are called the femoral condyles and epicondyles. But as I move down that, so the first part, if you say, what are the three parts of a muscle? Well, I know the first part of a muscle is going to be the origin. The second part of the muscle is going to be this region in here. And it's kind of a generic term, but really that's called the body of the muscle. So I've got an origin of a muscle, which is the femur or femoral condyles. I've got a body of the muscle, which is this main part of the muscle running down. And just as I showed you in what I call the muscle man, and I'll just draw some of this in here to show it's got a tendon-like connective tissue appearance. And since this I know has to be a bone, so that's going to be the calcaneus. Remember, the calcaneus is going to be an ankle bone. It's going to be a heel bone. It's going to be a tarsal bone. And since that muscle is going to have to attach to it, that muscle, that bone is going to be the eye. So that is going to be the eye or insertion. And the way I'm going to insert on there is by means of this structure here. And that's going to be called the Achilles tendon. So that's how we're going to kind of think of the big picture here. So we know that this muscle's got an O, the femur or femoral condyles. It's got a body, it's got an eye, the insertion, which is the calcaneus. Remember the calcaneus via the Achilles tendon. Well, it's got to have an A, right? So remember the A, or the action, is going to be plantar flexion. Because remember I said it's called the ballerina muscle. And of course, plantar flexion equals stand on your toes. Then I've got to have what else? Well, I've got to have some way that I can control this muscle. So I'm going to have an N. And an N is going to be the nerve supply. And as I said earlier, it's going to be also called the innervation. And the nerve supply equals the tibial nerve. So if you kind of think about the skeleton, and when you see where the bones, because you realize this muscle is sitting over the back of my leg, and my leg, remember, is going to start up here. First of all, before I get to the leg, I'm going to have my thigh up here. So remember, that's the femur. But my leg is going to be the tibia and fibula. So behind this muscle is actually going to be that bone called the tibia. So therefore, an easy way to remember that is the bone that sits behind this is the tibia, and the nerve supply for this muscle is the tibial nerve. And then I've got to have, remember I talked about things called synergists. So S-Y-N, remember S-Y-N is synergists. Remember, synergists are going to be muscles that are going to work with. So the synergists of this muscle are going to be muscles sitting right behind it. And that's going to be three muscles called the soleus and the plantaris and the tibialis posterior. So again, big picture, we got an origin, we got an insertion, we got an action, we got a nerve supply, we got a synergist, three of them. What's left? Antagonist, A-N-T-A. Remember, an anta or antagonist is going to work against, and that's going to be the muscle that's going to be sitting on the opposite side of the leg. So therefore, the answer to that question is going to be the tibialis anterior. So thinking the big picture here, just kind of think that if this muscle, the gastrocnemius, is responsible for plantar flexion or standing on my toes, and if I just told you that the tibialis anterior is going to be the antagonistic muscle, then therefore the action of that tibialis anterior must be to do the opposite, and therefore the tibialis anterior is going to lead to what's called dorsiflexion, which is standing on your heels. So if you recall, going back to bones in the introductory material, we talked about anatomical position. Just remember, anatomical position said I'm drawing you, or I'm looking at you with your palms facing forward. I'm looking at you standing erect. But remember, I'm also looking at you in the dorsiflexion position. I'm standing on your heels. Okay? So now we've got those pieces together. Again, remember, three main parts of a muscle: origin, body, insertion. And then as you go through this semester and go through the book, you'll see that there's a lot of muscles. Like I say, there's 657. And if you just, for a second, as you're going through this, look at your book, and like on page 137, you'll see an anterior view of what I call the muscle man with the names of all the muscles. If you go to page 138, you see a posterior view of the muscle man with all of the muscles that you can see from the posterior side. But then as you move along, you'll see that there's muscle tables. And the muscle tables literally go through each of the muscles, and they tell you different things. Like up here you'll see the name, this is your facial expression muscles, action, location, origin, insertion, nerve supply, synergist, antagonist. So that's how you're going to want to know some of this material. Now, I can't expect that everyone could possibly memorize all of these muscles, all of their origin, insertion, actions, innervations, synergists, antagonists. It's a daunting task to try and learn all that material. And so I will go through certain ones that I think are significant, so that if you're working as a nurse, if you're working as a doctor, if you're working as a physical therapist, whatever you go into, you'll at least have kind of the big picture of where that muscle is located. Because like I say, a lot of times I'll run into someone, I'll ask them a question, I'll say, well, where is that muscle located? Let's say, I don't know, I didn't really learn that. And so if you look at this page, which is on page 150, you'll see, sure enough, there's your gastrocnemius. And it's telling you what it's for. So that's the ballerina calf muscle, origin on the femur, insertion on the calcaneus, tibial nerve. And again, see how it says all four? So all four of these muscles work together. Gastrocnemius, soleus, plantaris, tibialis posterior. They're all working together to do that action of plantar flexion. So that's how we're going to know this material. But again, it becomes overwhelming, so I try and give you bits and pieces of it and not make you memorize certainly 657 muscles, because at the end of the day, it wouldn't be valuable to you. I mean, if you were going to be a orofacial surgeon, you certainly would want to know all of the muscles of facial expression, all the muscles of the face, where they came from, what their nerve supply. But again, there's always going to be variations. My muscles, my origin, insertions, and things can vary so much from you, between 5 people standing in a room right now. Each of us could have variations of it, so we have to kind of look at it. Not everybody is. These are kind of what I would call the standard man, realizing that there's variations throughout the population.